Welcome everyone. My name is Lamarcus, and in this video, we will delve into the Kendall and Spearman's correlation coefficients, which are essential for understanding relationships in data. So first, let's discuss the Spearman correlation. This method assesses how well the relationship between two variables can be described using a monotonic function. It's based on the ranks of the data rather than their actual values, which makes it ideal for non-parametric data. Now, onto the Kendall's correlation. It measures the ordinal association between two variables, focusing on the rank order, and is particularly useful for large data sets. It calculates the number of concordant and discordant pairs, providing a robust measure of association. In this session, we will first provide an overview of correlation in general. Next, we'll demonstrate how to tidy our data so that we can carry out the Kendall and Spearman's correlations. And next, we'll demonstrate how to conduct the Spearman's and Kendall's correlation within RStudio. Finally, we will explain when you will use one analysis as opposed to the other. So let's take a moment and look at how these analyses differ in terms of the types of association they are used for. With the Pearson's correlation, it is used strictly for a linear association. This means that a given change in x always and invariably results in the same predictable change in y, unlike the Pearson's correlation. The change with the Kendall and Spearman's correlation does not have to be in a linear fashion. Rather, it has to be a monotonic relationship. A monotonic change means that the change occurs in the same direction, whether it be positive or negative, but it does not always have to be linear. A good example of a monotonic change is y equals x squared. In this case, as the absolute value of x increases, y will also increase, yet not in a linear fashion. So there are a few other noteworthy differences between these types of correlation analysis. While the Pearson's correlation requires both variables to be continuous, the other forms of correlation stipulate that the variables can be either continuous or ordinal. However, I should mention that if any of the variables is nominal in nature, a correlation analysis cannot be performed at all. And also with a Pearson's correlation, both variables must resemble a normal distribution, that is your independent variable as well as your dependent variable. However, with the Kendall and Spearman's correlation, neither of the variables included has to follow a normal distribution. So the Pearson's correlation is said to be a parametric test because it has more rigid assumptions, such as normality. On the other hand, the Kendall and Spearman's tests are non-parametric, but they are more flexible. Generally, parametric tests are considered to be more powerful tests, and if you have the ability to use them, it is preferred that you do so. So in our current example, our first variable is body mass index. So body mass index is a standardized measure of a person's weight while also accounting for their height. Values above 30 are considered obese. The second variable in this example is self-reported exercise frequency. More specifically, in this case, respondents are able to provide the average number of days they engage in moderate exercise during a given week. In this scenario, our respondents are gathered from all across the United States. So in this example, our research question is, for this simple example, is there an association between BMI and the mean number of days engaged in exercise per week among adults within the United States? So many of the packages that we will be using in this session may be familiar to you by now. These include the Haven package, and then also the MEPS package to import MEPS data. So we can import the data in our RStudio using the read MEPS function. We can specify the year, which is in this case 2022, with the year command, and we select the type of data file with the type command. In this example, we specify FYC, which stands for the full year consolidated data file. As you may realize by now, the MEPS data has a multitude of variables. So we want to apply the select function in order to keep only the variables we'll be utilizing in this analysis. This is a very simple step that we have used before in this session. And so we're applying this to be able to retain the exercise and BMI variables. So we can use the summary command to obtain basic information about both variables contained within this particular abbreviated data set. Since they are both continuous in nature, we can use the summary command. And from this, we can examine the values for BMI and exercise frequency. And what we notice is that there are negative values, which does not seem to make sense for BMI nor exercise. For BMI, maybe, definitely we know that it does not make sense. There could be some people who have 0 days of exercise, but we know that there should not be like a value of negative 15. But there could be 0 values, but not negative values. So we apply a filter to remove the negative values from both the BMI and exercise variables. When we perform a summary of the filtered data set, we are able to see that all of the negative values for BMI and exercise have been removed. We intentionally leave out people who have 0 days of self-reported exercise due to the fact that this would skew the data. So we now conduct a histogram to evaluate the distribution of BMI. It appears to somewhat approximate a normal distribution, but it's a little bit skewed to the right. Whenever we conduct a Kendall or Spearman's correlation, however, we do not have to worry about the distribution being normal. We can still go ahead and apply those analyses. So now to the exciting part, at least for me, when I get a chance to do analysis. For our next step, we demonstrate how to conduct the Spearman's and the correlations test, Spearman's correlation test between exercise and BMI, as well as the Kendall's correlation. So this makes use of the core.test function. You can specify which version of the test to run in the method argument. We can see that the correlation coefficient is negative 1.70 for the Spearman's test and negative 0.122 for the Kendall's test. Both of them are significant with a p-value that is less than 0.001, which means that there is an inverse relationship between the days of exercise and BMI. So a higher frequency of days exercising is associated with a lower BMI. Although they have different names, a correlation value can range anywhere between -1 to +1. And so a value of 1 indicates a perfect monotonic relationship where every increase in one variable is always accompanied by an increase in the other variable. And a value of -1 indicates that a decrease in one variable is always accompanied by a decrease in the other variable. So because these two tests are so similar, you might be asking yourself, when is it appropriate to use the Kendall versus the Spearman's correlation? Actually, the Kendall's correlation is preferred in most situations, although it will probably have a smaller and more conservative correlation value. Kendall's correlation is more suitable to use in situations where there's a large data set, or if the correlations are strong and if there are any type of outliers. On the other hand, Spearman's correlation is preferred to use in situations where there's a small data set and the correlations are also smaller in magnitude. So let's reiterate our most important points. The Kendall and Spearman's correlation can both be used to evaluate if there's a monotonic relationship between two variables that are either continuous or ordinal in nature. And then the values for the correlation statistic range from -1 to 1. And higher absolute values indicate a stronger association. In most situations, the Kendall's correlation is considered to be more robust, especially whenever you're working with larger data sets. That's what you would prefer to use. So thank you for joining us on this session about the Kendall and Spearman's correlation. Our hope is that you are able to learn when these tools can be applied within an analysis. Hopefully, this will not be a difficult task for you to conduct in RStudio, and we have practical hands-on exercises for you to try in Codio. Warm regards.